Hey everyone, this is the 2019 AP FRQ number 3. So in this one, we're given the graph of f. We're told that f is a continuous function on the closed interval from -6 to 5, but you'll notice this graph only actually goes from -2 to 5, so that's important. This graph that we are shown is made of two line segments and a quarter of a circle that's centered at 5, 3. So the center of the circle is right here. And it is known that the point 3, 3 minus root 5 is on the graph of f. So part A asks us to find the value of the integral from -6 to -2 of f of x dx. So again, you'll notice the graph doesn't go that far, but they did give us that the integral from -6 to 5 of f of x dx is 7. So that's going to be important. We're going to first use our properties of integrals to break that up. So we're going to start by doing the integral from -6 to 5 of f of x dx, and we're going to say that that's equal to the integral from -6 to -2 of f of x dx plus the integral from -2 to 5 of f of x dx. Now what's nice is we already know from the givens that this integral is 7. And we know that this integral is what we're looking for. So -6 to -2 of f of x dx. And we are able to use the graph to actually find this one. This one, we're actually going to just find the area now, all the different areas that are under the curve. So from -2 to 5, so we're doing this entire piece. So we can see we've got this triangle that's up top, this triangle that's down below. Luckily, those will cancel out, but we're going to write them just so that we can make sure we show all of our work. So the first one is 1/2, the base is 1, the height is 1, then it's going to be a minus 1/2 times 1 times 1, so that takes care of those two. So I'm actually going to delete those off of our graph so they're out of the way. Now we have to do this teeny little triangle that's here. That's also underneath the curve again. So, or underneath the x-axis. So it's going to be a minus 1/2. The base is actually 1/2 and the height there is 1 because that point right there is actually 1/2, 0. And we can tell that by looking at the slope. The slope of that line segment is 2. So instead of going up 2 and over 1, if we go up 1, we would go over 1/2. Yeah. Um, all right, then where was I? Now we need to do this triangle to get us up to 2. So that's going to be 1/2. The base is 1.5, so 3/2. And the height is 3. And then I'm going to use a different color here so we can kind of show what's going on. So now we have to figure out how to find this red area. So remember, they told us that this is a semicircle. So what we're going to actually do then is we're going to make this 3 by 3 square. And if we subtract out the area of that quarter of a circle, we'll be left with that red portion. So to show that, I'm just going to write it underneath here. So we're going to do plus 9, because it was a 3 by 3, and then minus the area of that quarter of a circle. So pi, the radius is 3, and it's a quarter of a circle. So I know that that blue stuff's kind of written in 2 lines there, but we do know that this and this cancel each other. So let's go ahead and start simplifying some work here. So we've got 7 equals the integral from -6 to -2 of f of x dx. And let's see what we've got going on here. This is going to be minus 1/4 plus 9/4, and then plus 9 minus 9 pi over 4. And so, just as a reminder, this number that we get when we simplify is actually this area that we found there. So I'm actually going to simplify that up there. So that'd be 2 plus 9 is 11 minus 9 pi over 4. And we're going to need that as we move forward. So that's why I'm going to write it up there. So let's see. We get 7 equals this integral from -6 to -2. It becomes plus 11 minus 9 pi over 4. And so we're going to subtract the 11 and add the 9 pi over 4. So we get that the integral from -6 to -2 of f of x dx is equal to, what, 7 minus 11 is -4, plus the 9 pi over 4. So there we go. All right, so that one here was actually worth 3 points overall. So it was 1 point for just breaking up the integrals this way and saying that you can go from -6 to -2 and -2 to 5, just add them up. It was 1 point for actually getting this number right here. So finding the area under the curve on everything. And then it was 1 point for your actual answer. I know I wrote that a little differently than I normally do, but just because of space. Okay, moving on to part B. So now we're asked to evaluate the integral from 3 to 5 of 2f prime of x plus 4 dx. Well, the thing we have to remember is that what we were given up here was the graph of f. We don't really know anything about f prime. But what we do know is an integral means to take the antiderivative. So if we have f prime, the antiderivative is just f, the original function. So we can actually just take the antiderivative of this integral. So if we do that, it would be 2 f of x, right? The 2 doesn't matter, it's just a coefficient in front, but the antiderivative of f prime is just f, plus 4x plus c, right? And we're going to evaluate from 3 to 5. So this is going to be 2 times f of 5 plus 4 times 5, which is 20, plus c minus 2f of 3 plus 4 times 3 is 12, plus c. So now we can figure out from our graph what is f of 5 and what is f of 3. So we got a lot going on our graph here. Let me erase all of that so that we can see what's truly going on. Okay, we need f of 5, which is 0, so that's good, and f of 3, which we were given here in the given information at the top of the problem. So this cancels out to be a 0, so that's a whatever. But we're going to have 20 plus c minus 2 times 3 minus root 5 plus 12 plus c. So it's 20. We know the c's will cancel. That'll become minus 6 plus 2 root 5 minus 12. And so if we simplify that down, we're going to get that the integral from 3 to 5 of 2f prime of x plus 4 dx is equal to 2 plus 2 root 5. That's our final answer for that one. So part B here was worth 2 points. It was 1 for using that fundamental theorem of calculus to get your antiderivatives here, and then it was 1 point for your answer. Moving on to part C, let's see, what are we asked? So we're given this function g that's an accumulation function, and we want to find the absolute maximum of g. So in order to find an absolute max, we know we need the endpoints, but we also need the critical points. So we need to know when is g prime equal to 0. Well, we were given this accumulation function, so if I want to find g prime of x, I can just take the derivative of this integral, and so I can just get f of x. So that's going to be important as we look through here. For g prime of x to equal 0, it means where does f of x equal 0? So we're looking at those x-intercepts. So -1, 1/2, and 5. So as we make our table, we've got x and g of x. We know we're going to start at -2. We have a critical point at -1, a critical point at 1/2, and an endpoint at 5. All right, so we're just going to find the values of those integrals. So here's our function g of x. So the integral from -2 to -2, I'm not even going to write it out. We know it's just going to be 0. But now I'm going to do the integral from -2 to -1 of f of t dt. So the area between -2 and -1 is just that little triangle there. So it's 1/2, base is 1 and height is 1. So it's just a 1/2. And then at 1/2, so we're going to do the integral from -2 to +1/2. So I'm going to erase kind of what's going on there. So from -2 to -1 is that first triangle that we did that was a 1/2. This triangle would be a -1/2 because it's the same triangle but underneath the x-axis. And so we're really only focused on this little triangle right there, which is going to be 1/2. The base is 1/2 and the height is 1. So this is an area of, it's got to be negative because it's under the x-axis, so it's -1/4. Again, that's because those two red triangles cancel. You should show your work. I'm just trying to minimize the time I spend writing on here. Okay, and then 5. So this is the integral from -2 to 5. Oops, I wrote f. I was getting ahead of myself there. -2 to 5 of f of t dt. And this is why I said in part A that it was important for us to write what that value was. So it was 11 minus pi over 4. 9 pi over 4, sorry. Because now we don't have to do all that work again, right? We already did it in part A, so we don't want to have to write it again and waste our time doing it. So we're looking for the absolute maximum. So the highest value here is that 11 minus 9 pi over 4. So the absolute max is 11 minus 9 pi over 4, and that's at x equals 5. Part C here was worth 3 points. So it was 1 point for showing that you know that g prime of x is equal to f of x. It was 1 point for including your critical values. And then it was 1 point for your answer. All right, and last but not least, we've got part D here, which is a limit question. So the limit as x approaches 1 of all this stuff. Well, remember, the first thing you're supposed to do with a limit is, if you can, plug it in. So we're going to plug in 1 and hope it works. And if not, we can use L'Hopital's rule. So if we plug this in, we're going to get 10 to the first power minus 3 f prime of 1 all over f of 1 minus arctan of 1. So there's a lot of things we kind of have to piece together on here. So first of all, let's go ahead and do f prime of 1. So that means we want the slope of f at 1. So at x equals 1, we're right here. So we just want the slope of that line, which is positive 2. So on the top here, we just get 10 minus 3 times 2. And then all over, we need f of 1, which is just a function value at 1. So the function value at 1 is just 1. And then minus, we need the arctan of 0. So I'm going to use a different color here, and I'm just going to kind of write a note. The thing you have to remember about arctan is it's the inverse tangent. So if you have arctan of 1, it's really asking you, where is tangent of theta equal to 1? All right, so if you remember that tangent is equal to sine over cosine, then when sine and cosine are equal, we would have a tangent of 1. So we know that that is at pi over 4, right? It's 45 degrees. So if we just go ahead and simplify, I'm going to write the original. The limit as x approaches 1 of 10 to the x minus 3 f prime of x all over f of x minus arctan of x. That's going to equal, on the top there, we get 10 minus 6, which is 4. And on the bottom, we get 1 minus pi over 4. And that's actually just our answer. So we luck out that we were able to just plug in 1 and find all the values, and we were good to go. This one is just 1 point for getting the answer. Thanks for watching.